Hi everyone. Today's lesson will be conducted by Yannick White. Our topic for today is complex conjugates. The objectives of this lesson are 1. Define complex conjugates. 2. State what complex conjugate is used for in real life. 3. Find the complex conjugate of a number. 4. Solve problems related to complex conjugates. What is a complex conjugate? A complex conjugate of a complex number is that number that the sign of the imaginary part is reversed. Now let's look at these two complex numbers, a plus bi. A complex number has two parts. What are those two parts? Do you remember? It has a real part and an imaginary part. Very good. Now let's look at the sign of the imaginary part. So this is my imaginary part. What is the sign of my imaginary part? It is plus. So for us to get the conjugate, we change the plus to minus. Let's look down here. What is the sign of imaginary part? Minus. So we change our minus to plus. Let's take a look what it is used for. Complex conjugate is used for rationalization of complex numbers, finding the amplitude of polar form of a complex number. One application of a complex conjugate in physics is finding the probability in quantum mechanics. And remember, complex conjugate is very useful. Conjugate of a complex number. For us to find the complex conjugates of a complex number, we simply change the sign of the imaginary part of the complex number. Also remember that conjugate is written with a bar over it, as shown here. Some books may have a bar, some will not. So let's look at this complex number, C plus DI. What is the sign of the complex, the imaginary part? The sign of the imaginary part is plus. So we change the sign to minus. So the complex conjugate of C plus DI is C minus DI. Let's look at this one. C minus DI. What's the complex conjugate for C minus DI? What would we change? Yes, we will change the sign of the imaginary part. The sign of the imaginary part here is minus, so we will change it to plus. Let's take a look at some examples. Find the complex conjugate of the following questions. Number 1, 4 plus 7i. So is 4 the imaginary part? No. Is 7i the imaginary part? Yes. What is the sign of the imaginary part? It is plus. So we're going to change this plus to a minus. So what would be the answer? So the complex conjugate of 4 plus 7i is 4 minus 7i. Let's look at another example. 1 minus 3i. What is the sign of the imaginary part? It is minus. So what would we change it to? Plus. Very good. So what would be our answer? 1, the complex conjugate of 1 minus I is 1 plus 3i. Very good. Let's look at another example. Suppose I have minus 4 minus 3i. What is the imaginary part? Minus 4? No. Minus 3i? Yes. So my imaginary part is minus 3i. But we are only going to change the sign of the imaginary part. What's the sign of the imaginary part? It is minus. So we change it to what? Plus. Very good. What's the answer of our conjugate? Minus 4 minus 3i is minus 4 plus 3i. Pause the video. Take a look at the examples before. Refresh your memory. Go through them again. And let's continue. Multiplying a complex conjugate by its complex number. This is a special property. Now, if my complex number is 4 plus 7i, what is my complex conjugate? My complex conjugate is 4 minus 7i. Let's multiply. Let's expand these two brackets. 4 plus 7i and 4 minus 7i. So let's go. Let's read it together. 4 times 4 is 16. 4 times minus 7i is minus 28i. 7i times 4 is 28i. 7i times minus 7i is minus 49i squared. What do you remember about I squared? Yes, I squared is minus 1. So if we have minus 1, we can replace it with I squared right here. We can substitute it. When we substitute it, we will have minus 49 times negative 1. And that will give me 49, a positive 49. So let's continue. Minus 28i plus 28i. This gives us what? 0. So our answer would be 16 plus 49, which is 65. Do you realize that there is no imaginary part? Yes. When you multiply a complex number by its complex conjugate, you only get a real number. Let's try another example. If I have 1 minus 3i, what is the complex conjugate? The complex conjugate is 1 plus 3i. Let's expand the brackets. 1 times 1 is 1. 1 times 3i is 3i. Minus 3i times 1 is minus 3i. Minus 3i times 3i is minus 9i squared. What do you remember about I squared? Yes, I squared is minus 1. Now, if I replace I squared with minus 1, then minus 9 times minus 1 would give me a positive 9. 1 plus 9 is equal to 10. Very good. Let's look at division. So the complex conjugate is used to help complex division. The trick is to multiply the top and the bottom by the conjugate of the denominator. All right, let's try this example. 2 plus 3i divided by 4 minus 5i. Now, for us to find the complex conjugate of the denominator, it would be 4 plus 5i because we change only the sign of the imaginary parts. Now, let's multiply by the conjugate of the denominator, which is 4 plus 5i. So the complex, so So the complex conjugate, as I said, is 4 plus 5i. Now let's multiply. 2 times 4 is 8. 2 times 5i is 10i. 3 to I times 4 is 12i. 3i times 5i is 15i squared. Now let's do the denominator. 4 times 4 is 16. 4 times 5i is 20i. Minus 5i times 4 is minus 20i. And minus 5i times 5i is minus 25i squared. What do you realize about I squared? Do you remember? Yes, I squared is minus 1. So if I squared is minus 1, we can substitute it and get minus 15 and positive 25. Now let's simplify this. For us to simplify this, what do you think we need to do? Can we add 8 plus 10i? No, they are on like terms. So we have to find the like terms. So 8 and 15, 10i and 12i, 16 and 25, and 20i and 20i. Very good. So let's simplify. So 8 minus 15 give us minus 7. 10i plus 12i give us 22i. 16 plus 25 gives us 41. But what happened to 20i minus 20i? 20i minus 20i give us 0. Now let's simplify this in the form complex number. Let's write it in the form a plus b, where we have a real part and an imaginary part. So minus 7 divided by 41 plus 22i divided by 41. And this is our complex number, written with a real part and an imaginary part. Now, final, let's look at some very important points of this lesson. The product of a complex number and its conjugate is a real number. The sum of a complex number and its complex conjugate is a real number. If a quadratic equation with a real coefficient has two complex roots, these roots are conjugate. And always remember, every complex number has a complex conjugate. Now here is an activity. Go pause the video, try these, and then you can go continue the video and go to the end where the answers would be, just to help you. So go over with the lesson, pause the video, and then try these. Let's see. Have a good day. Remember, some of these information, not only my information, so here is my reference. So you can use some of these reference if you would like also. Have a lovely day. Let's just refresh our memory. Here's the answers. Let's refresh our memory with a little. And that's the end of my lesson. I am Yannick White. Have a lovely day.